ஸோ போன கிளாஸில் வந்து அனலிட்டிக் ஃபங்க்ஷனை பற்றி பார்த்தோம் போன யூனிட்டில். இப்போ இந்த யூனிட்டில் என்ன பண்ணுறோம்னா அதோட அப்ளிகேஷன் எங்கே இருக்குன்னா காம்ப்ளெக்ஸ் இன்டகிரேஷன். நம்ம ரியல் இன்டகிரேஷன் நமக்கு தெரியும் இல்லையா? சப்போஸ் இன்டகிரல் 0 to 1 x dx. இப்போ இந்த ஃபங்க்ஷன் வந்து இந்த இன்டகிரண்ட் இஸ் அ ரியல் வேல்யூட் ஃபங்க்ஷன். இந்த instead of ரியல் வேல்யூட் ஃபங்க்ஷன் சம்டைம்ஸ் மே a காம்ப்ளெக்ஸ் வேல்யூட் ஃபங்க்ஷன். அப்படி வரும்போது என்ன பண்றோம், அதை காம்ப்ளெக்ஸ் இன்டகிரேஷன் அப்படின்னு நம்ம சொல்றோம். காசிஸ் இன்டகிரல் தியரம் ஆர் காசிஸ் ஃபண்டமெண்டல் தியரம். இதான் நம்ம ஸ்டேட்மெண்ட் என்னன்னா, if f of z is analytic and its derivative f dash of z is continuous at all points on and inside a simple closed curve C, இப்படி இருந்துச்சுன்னா then integral over C f of z dz equal 0. இந்த f of z என்ன சொல்றாங்க, analytic function. So analytic function என்ன, suppose f of z is analytic at a point அப்படின்னா என்ன, so at z முன்னாடி நம்ம பார்த்திருக்கோம். f of z is analytic at z naught அப்படின்னா it is differentiable at that point and also each and every point at some neighborhood of that. So this is z naught, this is some neighborhood, each and every point in this neighborhood at that point also this function is what, differentiable, right? அப்படி இருந்துச்சுன்னா அது அனலிட்டிக் நம்ம முன்னாடியே பார்த்திருக்கோம். இப்போ அந்த மாதிரி கண்டிஷன் f of z is analytic and its derivative அந்த ஃபங்க்ஷனோட டிஃபரன்சியேஷன், தட் இஸ் ஃபர்ஸ்ட் ஆர்டர் டெரிவேட்டிவ் f dash of z, அது என்னவா இருக்கணும், கண்டினியூஸா இருக்கணும். So at all points on and inside a simple closed curve. இப்போ சப்போஸ் சிம்பிள் closed curve இங்க எடுத்துட்டோம் அப்படின்னா, so this is a simple closed curve சீன் வச்சுக்கலாம். இப்போ இதுல இருக்கிற ஒவ்வொரு பாயிண்ட் on this curve or inside அந்த பாயிண்ட்ல என்னவா இருக்கணும், கண்டினியூஸ் அண்ட் அனலிட்டிக்கா இருக்கணும். அப்படி இருந்துச்சுன்னா so integral over this region R, then f of z dz, integral over C f of z dz equal 0. Clear? Okay. So this is a statement of Cauchy's fundamental theorem or Cauchy's integral theorem, right? What will be the application of this theorem? Using this theorem, so we can evaluate some integrals, right? So for example, suppose we want to evaluate integral over C e power z dz, where C is a unit circle, right? So இங்க Cங்கிறது unit circle, என்னது, a circle with center origin radius 1. So these are simple closed curve C. So I have to evaluate this integral over this region, right? Integral over along this curve C, okay? So for that we apply this Cauchy's integral theorem. Simply we have to verify that, so this function, you take it as later f of z equal e power z. While applying Cauchy's integral theorem, you can verify that this function f of z is analytic and its first order derivative is also continuous at all points inside and on this curve C. Then we can apply the Cauchy's integral theorem, right? So the sufficient condition is nothing but one. Suppose f of z equal to u plus iv. இது முன்னாடி நம்ம பார்த்திருக்கோம் போன யூனிட்ல. ஒரு ஃபங்க்ஷன் அனலிட்டிக்கா இல்லையான்னு எப்படி செக் பண்ணோம். The first order derivative of this real valued functions u and v, that is ux, uy, vx and vy are continuous and also the derivative exists, and the CR equation ux equal vy and uy equal minus vx இது முன்னாடியே பார்த்தோம். இப்போ இந்த கண்டிஷன் சாட்டிஸ்ஃபை பண்ணுச்சுன்னா இது வந்து என்ன சொல்றோம், அனலிட்டிக். இது சஃபிஷியன்ட் கண்டிஷன் முன்னாடி பார்த்தோம். இப்போ இதை சாட்டிஸ்ஃபை ஆகுதா இல்லை நம்ம செக் பண்ணிக்கலாம். So e power z வந்து என்னது, so we can write z, you take it as z equal to x plus iy, then e power z equal to e power x plus iy, which is equal to e power x into e power iy. So e power x into e power iy is nothing but what, cos y plus I sin y. So we can take it as u equal to e power x cos y and v equal to e power x sin y. the derivatives of this u and v are exist. The first order derivatives ux, uy and vx, vy are exist. And this it is an exponential function. It is a trigonometric function. Always it's a continuous one. Therefore, the first order derivative exists, and it is continuous. And then it satisfies this ux equal to vy and uy equal to minus vx. So therefore, this e power z is analytic. So therefore, we can take any point in this. It satisfies that condition inside C and on C. Okay. So we can apply Cauchy's integral theorem. What is the statement? So integral over f of z dz equal to 0, where f of z is analytic and first order derivative is continuous, right? So here e power z is analytic, and its first order derivatives are continuous. So therefore, we can apply this theorem. So e power integral e power z dz equal to 0. The value of integral over c power z dz equal to 0. Here this is application of this Cauchy's integral theorem. This is one example. Okay. So can any function can verify that the function is analytic and its first order derivatives are continuous, right? Then we can apply Cauchy's integral theorem. Clear? Right. The next theorem is Cauchy's integral formula. Cauchy's integral formula and statement. If f of z is analytic inside and on a simple closed curve C that encloses a simply connected region R, and if A is any point in R, then f of A equal 1 by 2 pi I into integral over C f of z by z minus a dz, where C is described in the anti-clock questions. So that is a statement of this Cauchy's integral formula. So f of analytic na namakku enna theriyum. So inside and on a simple closed curve C. F of z வந்து எப்படி இருக்கு? Analytic on and inside a simple closed curve C. The simple closed curve C எப்படி இருக்கு? Encloses a simply connected region R. The simple closed curve C வந்து so is a simple closed curve, right? It encloses, so this region, this C is anti-clockwise sense. This region R is a simply connected region. The simply connected region and or region kulla or simple closed curve. So draw pannu appadina. So the simple closed curve is shrunk to a point that cannot be leaves in that R. Appadi irundhuchna that region is called what? Simply connected region. Okay. So in the simple closed curve in the region or simply connected region enclose பண்ணது. அப்படி இருந்துச்சுன்னா you take any point inside this region. So A is any point in R. So அப்படி இருந்துச்சுன்னா this is a result. So f of A equal 1 by 2 pi I into integral over C f of z by z minus a into dz is the result. Problem point of view எப்படி எடுக்கலாம் அப்படின்னா integral over C f of z by z minus a dz equal to cross multiply. So 2 pi I into f of a. So it can be used to evaluation of some integral size. That is the application of this Cauchy's integral formula. So integral over C f of z by z minus a dz equal to 2 pi I into f of a. So these are, we can rewrite this result as like this. Okay, integral over C f of z by z minus a dz equal 2 pi I into f of a. Next one, Cauchy's integral formula for the derivatives of an analytic function. Remember these results, right? So integral over C f of z by z minus a the whole square dz equal 2 pi I by 1 factorial into f dash of a. So Cauchy's integral formula என்னன்னு பார்த்தோம். Integral over C f of z by z minus a dz equal 2 pi I into f of a. Now denominator whole squared வந்துருந்துச்சு அப்படின்னா can apply this derivative formula. F of z by z minus a the whole square dz equal 2 pi I by 1 factorial into f dash of a. Suppose whole cube இருந்துச்சுன்னா f of z by z minus a the whole cube dz equal 2 pi I by 2 factorial into f double dash of a. So in general, integral C f of z by z minus a whole to the power n plus 1 dz equal 2 pi I by n factorial into f nth derivative of a, right? So the bottom part, so integral over C dz by z minus 2, where C is the circle whose center is 2 and radius is 4. So I have to evaluate this integral, right? Either you can apply integral theorem or integral formula. So better you can apply integral formula. So since it is of the form integral over C f of z by z minus a dz, which is equal to what? So by integration, by Cauchy's integral formula, right? Integral over C f of z by z minus a dz equal, so 2 pi I into f of a. So this is a formula. You compare with, so integral over C f of z is 1. So 1 by z minus 2 dz equal 2 pi I into a is 2 here, so f of 2. So you have to find out the value of f of 2, right? For that we had, while applying this Cauchy's integral formula, we can verify that the conditions. What are the conditions? F of z is analytic and a is any point inside C. Okay, what is C here? A circle with center 2, that is 2 comma 0 and radius 4. So this is 0, this is x-axis and this is y-axis, and this is 2 comma 0. The center is 2 comma 0 and radius 4. இது வரைக்கும் வருமா? இங்கே என்ன வருவாங்க? radius 4 வந்துச்சுன்னா 6 comma 0 இந்த மாதிரி இருக்கும் circle. Yeah. So this is a closed curve C. So whether this point 2 is whether inside or not. So 2 is nothing but 2 comma 0. That point is inside the region. So we can apply this Cauchy's integral formula. So where f of z equal to 1, what is f of 2? This is a constant function. So f of t is also 1. We can replace it. So 2 pi I into f of 2 is 1. So this is equal to 2 pi I. So therefore integral over C dz by z minus 2 equal to 2 pi I. So that is the application of Cauchy's integral formula. We can evaluate some integrals like this. Okay, right? So see this problem. So integral over C z square plus 1 by z square minus 1 into dz, where C is the circle of unit radius with center at z equal to 1. So we can rewrite this function, right? So z squared plus 1 by z squared minus 1 dz. So I can replace this as z squared plus 1 by z squared minus 1 is what? Z plus 1 into z minus 1 into dz. நம்ம Cauchy's integral formula apply பண்ணோம்னா denominatorல வந்து ஒரே ஒரு factor தான் இருக்கணும். So then only we can apply Cauchy's integral formula. Another integral over C f of z by z minus a dz equal 2 pi I into f of a. இதில் வந்து எந்த இந்த ஏங்கிறது a is of any point inside R. இப்போ இங்கே ரெண்டு பாயிண்ட் இருக்கு, a equal to minus 1 and a equal to 1. So which point is lies inside? What is the region here? C is a circle of unit radius at center is 1 comma 0. So this is x-axis and this is y-axis. This is 1 comma 0, that is the unit radius. So this length is 1, this is radius. So like this. So this is a C, right? So here the 2 points, z equal a equal to minus 1 and a equal to 1. So a equal to minus 1 obviously lies outside. So a equal to 1 is lies inside. 1 is nothing but 1 comma 0, right? So we can rewrite this as z squared plus 1 by z plus 1 by z minus 1 dz. You consider this is f of z. You compare with this formula. So this is nothing but f of z equal to this, right? So we can apply Cauchy's integral formula. So we can write this as, so 2 pi I into f of 1, right? So a is 1 here. So this 1 is lies inside, right? So 2 pi I into f of 1. So the f of 1 oda value நம்ம calculate பண்ணோம். So where f of z equal to numerator z squared plus 1 by z plus 1. So this is f of z. So what is f of 1? For 1 plus 1 by 1 plus 1, so this is equal to 1, right? So 2 pi I into 1. So again 2 pi I, right? So So this is a required answer. So integral over c z square plus 1 by z square minus 1 dz equal to 2 pi I. Clear? The next problem, so evaluate so integral over c z dz by z minus 1 into z minus 2 the whole square, where c is a circle, modulus of z minus 2 equal to 1 by 2 using Cauchy's integral formula. For Cauchy's integral formula or Cauchy's integral formula for the derivatives of analytic function ரெண்டுல எது வேணா அப்ளை பண்ணலாம். அதுக்கு என்ன பண்ணணும், இந்த ஏங்கிற பாயிண்ட் எந்த பாயிண்ட் வந்து லைஸ் இன்சைட் அப்படின்னு நம்ம பார்க்கணும். இது ரெண்டு கம்பேர் பண்ணி என்ன கிடைக்குது, a equal to 1 and a equal to 2 இல்லையா. So whether which point is lies inside R. What is R here? The units, so the circle of center 2, 0 and radius 1 by 2 இல்லையா. Modulus of z minus 2 equal to 1 by 2 என்ன, a circle with center 2, 0 and radius 1 by 2. So 2, 0 na, this is 1 and this is 2, so 2, 0. So radius 1 by 2. அப்படி இருக்கலாம் இல்லையா. So this is a region R, right? Okay. So this point is 1.5, that is 3 by 2, right? This one is 2, this one is 2.5, that is 5 by 2. Okay. So a equal to 1, a equal to 2, which is lies inside. So a equal to 2 is lies inside, right? So a equal to 1 is lies outside. So this point is lies outside, this one is lies inside. So we can rewrite this as integral over c z dz by z minus 1 into z minus 2 the whole square, which is equal to integral over c z by z minus 1 by z minus 2 the whole square into dz. You consider this is f of z. Now which is of the form what? Integral over c f of z by z minus a the whole square dz equal to 2 pi I by 1 factorial into f dash of a. So this is a formula. So here a is what? 2. So 2 pi I by 1 factorial into f dash of 2, where f of z equal to z by z minus 1. Z by z minus numerator தான் இது f of z, right? நமக்கு என்ன வேணும், f dash of 2 வேணும். What is f dash of z? We'll differentiate it. So it is u by v formula. Z minus 1 the whole square, z minus 1 into 1 minus z into 1. Whenever the z minus 1 minus z by z minus 1 the whole square. So f dash of 2 equal to dash of 2 in over z equal to 2 potena. So minus 1 by 2 minus 1, 1 squared 1, so minus 1. But therefore 2 pi I by 1 factorial is 1 into f dash of 2 is minus 1. So this is equal to minus 2 pi I. So which is the required answer, right? Next problem. So use Cauchy's integral formula. So to evaluate integral over c sin pi z squared plus cos pi z squared by z minus 2 into z minus 3 dz, where c is a circle, modulus of z equal to 4. இப்போ இதில் Cauchy's integral formula அப்ளை பண்ணால் டினாமினேட்டரில் ஒரே ஒரு ஃபேக்டர் தான் வரணும். இங்கே ரெண்டு ஃபேக்டர் வந்திருக்கு. இப்போ இதில் எந்த பாயிண்ட் வந்து லைஸ் இன்சைட் அப்படின்னு நம்ம பார்க்கணும், ரைட்? ஸோ ஹியர் a equal to 2 and a equal to 3, where c is modulus of z equal to 4. So modulus of z equal to 4 na a circle with center origin radius 4, right? This is x axis and this is y axis, 0, 1, 2, 3, 4, something like this. So this is a circle with center origin radius 4. So this is the region. So here a equal to 2 and a equal to 3 both are lies inside. இப்போ ரெண்டு பாயிண்ட்டும் என்னதான் இருக்கு, இன்சைடா இருக்கு. இப்போ இதை எப்படி எவாலுவேட் பண்றது? ஃபர்ஸ்ட் இது என்ன பண்றோம்னா பார்சல் ஃபிராக்ஷன்ல ஸ்ப்ளிட் பண்ணிக்கேன். இப்போ நியூமரேட்டர் வந்து நான் 1 எடுத்துட்டு இப்படி எடுத்துக்கிறேன் நான் 1 by z minus 2 into z minus 3. இதான் பார்சல் ஃபிராக்ஷன் பண்ண என்ன வரும், a by z minus 2 plus b by z minus 3 is equal to we take LCM, z minus 2 into z minus 3, a into z minus 3 plus b into z minus 2. We compare with numerator, so 1 equals a into z minus 3 plus b into z minus 2. You have to find out the values of a and b. So put z equal to 2. So you may get 1 equals a into z equal to 2 minus 1. So a equal to minus 1. Put z equal to 3. You get 1 equal to this is 0. B into 1. So b equal to 1. So therefore, which is equal to 1 by z minus 2 into z minus 3 equal to a is minus 1. So minus 1 by z minus 2 plus 1 by z minus 3. You multiply on both sides the numerator. That is sin pi z square plus cos pi z square on both sides. What is that? So numerator is multiply panina. It is equal to minus வெளியெடுத்துறலாம். So sin pi z square plus cos pi z square by z minus 2 plus sin pi z square plus cos pi z square by z minus 3. So integrating on both sides, so integral over c dz equal integral over c into dz, integral over c into dz, right? Now you can apply causes integral formula. So this is of the form what? Integral over c f of z by, so both these integrals of the form f of z by z minus a dz equal 2 pi I into f of a. This is the formula. So here minus of 2 pi I into, so f of a is here 2, so f of 2 plus in this integral 2 pi I into f of 3. So what is f of z? So where f of z equal sin pi z square plus cos pi z square. So f of 2 equal to, so sin z equal to 2 or 4 pi plus cos 4 pi. So sin 4 pi is 0, then cos 4 pi is 1. So this is equal to 1. So f of 3 equal to your sin 3 9 pi plus cos 9 pi. So sin 9 pi is 0, so cos 9 pi is minus 1. This is equal to minus 1, right? Then replace it. So minus 2 pi I into f of 2 is 1 plus 2 pi I into f of 3 is minus 1. So minus 2 pi I minus 2 pi I is equal to minus 4 pi I. So this is the required answer.